Okay, hi everyone. Today we'll discuss the next topic that is the functional testing versus structural testing. Okay. What is the functional testing versus the structural testing? See here. Okay, functional testing versus the structural testing. So here the functional testing with respect to functional testing, as far as the functional testing considered. We mainly concentrate on the functionality of application. That is what the module does or what the software does is tested. That is what functional testing. But in case of a structural testing, only the structure of the program, or structure of the module is tested. So first we'll see what is the functional testing. See, in case of functional testing, we'll test the application or we'll test the software or the application or module. So what the software does is tested. What actually does the what the software does means what is the actual functionality of application? What is functional? What is the actual functionality of the software is tested. Now the functionality of a model is tested and the structure is not considered. See here in case of functional testing, we mainly concentrate on the functionality of application. We are not going to consider the that is the structure of the model, structure of the application, or structure of the model. See here in the test case, based on specification and internal models that consider are also considered means test cases based on specifications or test cases based on specifications and the internal models. So based on a specification and internal models are also considered here in case of functional testing. The specification based on the test case specification and internal models. So what are the internal models? The models are nothing but the internal models. Okay, here the almost all complete models are considered here in case of functional testing because we carry out the testing process on models. Okay. So here the modules are nothing but internal models are also considered. Now this type of testing is also known as the black box testing because why is this a black box testing means? See, in the black box testing, we actually test what is the functionality of application. That is why this functional testing is also known as the black box testing. Functional testing is nothing but a black box testing. So just remember what is the points like. See, what is the use of functional testing here? The functional testing is used to check the functionality of an application or check the functionality of a module. Okay. Now here the functionality the only we concentrate only on the functionality of application. We are not going to consider the structure of a module or structure of application. Here, the most important here, the test cases are based on specification. Based on specification, internal models are also considered. The specification and internal models are also considered, and this is also called as the black box testing. These points are more than enough, and just remember these points. Next is structural testing. So what actually the structural testing means? See what happens, the structure of a program differs at the different levels. Means the structure may change at the different level of a testing process or a different level of development process. The structure of a application, the structure of a program or structure of a model may differ at the different levels of a testing process or a development process. So at the component level, the structure is the code. At the component level means at the initial stage, at the initial level or at the initial stage, that is a unit level or a component level, the structure is the code. The structure is nothing but the code. Means here the actual code we are going to test. At the component level, the structure is the code. Means that means structure is the code means here at the component level or component testing or unit testing, we actually test the code. So that is the meaning of the second point. At the component level, the structure is the code. And the structure is the code. But at the integration level, the structure is the tree diagram, shows the interconnection. So at the integration level, but as the first point, as you see in the first point, the structure testing, structure of the program differs at the different levels. Means it might be at different levels. The structure of code may be different, or structure of a model are different at the different levels. So in the third point, at the integration level, see at the integration level, the structure is a tree diagram. So what is the tree diagram here? The tree diagram denotes or represents the interconnection, the interconnection So actually, the generally tree representation of anything is used to denote or to represent the interconnection of a different models. So here, with respect to testing, the tree diagram at the integration level, the structure is denoted by the tree diagram. So now the tree diagram is which represents the interconnection of a model. Okay, interconnection of a different model. Now structural testing at the component level. At the component level, the test the implementation of the program. At the structural testing at the component level, we used to test the implementation of the program. Actual implementation of the program is tested at the component level. So actual implementation is tested at the component level. Okay. So now coming to the next point, that is we have different types of the structural testing. So you can see that there's different types of structural testing, structural testing or different types. You can see that structural testing involves these three kind of coverages. The first one is statement coverage, second is the condition coverage, the third one is the path coverage. So coverage here, the statement if you see here, the statement coverage, condition coverage, and path coverage. So coverage, the meaning coverage, the coverage meaning here, the statement coverage means at least ensure that we are going every statement should be executed at least once. See here, in the condition coverage means at least all the looping condition or a loop condition statement should be covered at least once or executed at least once. And the path coverage means every path is covered at least once or executed at least once. So here we'll discuss in details. Now the statement coverage, these three comes in the structural testing. Okay. Now statement coverage. Coming to the statement coverage, here the statement coverage, see, it ensures that each and every statement is executed. Each and every statement should be executed at least once. So that is what the statement coverage means. We try to cover every statement. We try to cover every statement. That is the meaning here. The statement coverage. At the first in the first point, we can see here. Ensure that each and every statement is executed at least once. Now, it is advisable to ensure every line of code is executed at least once. So both the statements are same only. So advisable to ensure every line of code executed at least once. Now here we use the profilers. We use the profilers as a tool. Now the profilers are used to carry out this testing, this statement coverage testing. Now profilers are just like a tools. Now what is the use of profilers? The profiler indicates that the number of times each line in the code is executed. So how many times that particular code or that particular line of code is executed. Okay, that is we use for that purpose we use the profiler. Profilers are nothing but the tools we use for structural testing. Okay, now here the profilers also indicate which line of a code have been executed and which line have not been executed. So in the statement coverage, what is the meaning of statement coverage? Every statement has to be executed at least once. To ensure that every statement has to be executed once, and we use the profilers. We profilers as a tool to check the statement coverage. Now, what is the profiler? The profiler used to check the number of times each line has been executed, and it also indicates that which statement or which line of a code is executed and which line have not been executed. So that is what the statement coverage here. Okay, next is the condition coverage. Okay, what actually the condition coverage is? Condition is nothing but a if-else statement or some conditional statements. See here, in the case of conditional coverage, so what happens? Actually, in a branch coverage, each and every branch option is taken, and the input is given such a way that each branch is executed at least once. So here, a similar way, in the statement coverage, we check every statement has to be executed at least once. Similarly, that in the condition coverage, every condition has to be tested at least once. Means every condition has to be executed at least once. So we develop a test case in such a way that every condition has to be tested at least once. Every condition code or every condition statement has to be executed at least once. Okay, see here, for example, we have if statement here. If A is greater than 6 and B is less than 6. Okay, so now see, if this condition is true, then only if then else, here if then else. If condition true, this statement executed. Else, the second statement is executed. Now, we test in such a way that we develop a test case in such a way that this if condition should always see for every conditional statement. We design a test cases like this condition should be true and this condition should be false. At least once it should give the true. It becomes a true, and at least once it should become a false. So in such a way that every possible conditions we use to test within a condition coverage. The condition coverage is so every branch coverage or every conditional statement has to be executed at least once. Okay. Now here, within this, the condition coverage, there is a formula. There is a formula. The condition coverage in percentage equal to the number of conditions executed divided by the total conditions. The number of conditions executed. Remember the condition coverage. There is a formula. Condition coverage equal to the number of conditions executed and divided by the total number of conditions multiplied by 100. That is what the percentage. Total number of conditions executed, we divide it by total number of conditions and we multiply it by 100 because we are calculating the percentage. Here, the next is the path coverage, and the third one is the path coverage. Here, in case of a path coverage, what actually happens in case of a statement coverage, every statement we are checking at least once. It should be executed at least once. But in case of condition coverage, every condition should be executed just once. Similarly, the path coverage. The path coverage ensures that the path is executed at least once. Now here the path. Path means we develop flowcharts. We develop a flowchart. In C programming is studied what is how to represent a program with a flowchart, how to represent the conditions with a flowchart. Now this flowchart is considered as a path here. Now this, for example, you are checking any condition. For example, if A is greater than 0. So if A is greater than 0, there are two conditional statements. If yes means if this condition is true, the another path we take another path and we perform some action. If condition is false, we take another path and we will perform another operation. See, similarly we represent those conditional statement, or we represent that conditional statement by using a flowchart. By using a flowchart. Now this flowchart is considered as the path here because the conditional statement has the two paths. One is yes and one is no. So that is what we consider. The flowchart is considered as the path here. Now, see, the path coverage ensure that each path is executed at least once. Now, each path has to be executed. Now, convert a given program into flowchart. That is what I said. We convert the program into flowchart, and they will know the pictorially how many paths are there. Okay. In case of if statement, we have only two paths, because one is true, one is false. Similarly, different conditions may be having a different path or many number of paths. Okay, so depending on the flowchart, we carry out the path coverage. Means at least one path should be executed. Every path should be executed at least once. Okay. Now, design test case ensure that each path is tested at least once. So that is what I said. Now, design a test case. We develop a test cases to ensure that each path is executed at least once. Okay. If, for example, in case of a if-else statement or if statement, let us take an example of a if statement. We should design a test case such a way that once the condition should return true and one more condition should be false only. Because if that is true, it will take the if statement takes another path. If it is false, it will take one more path. Okay. Now this is what the path coverage. Okay. Next, we will move on to the next topic, that is the mutation testing. Okay, mutation testing. So one more is that functional coverage is there. I think the functional coverage. Similarly, what is the similar way? What is the use of functional coverage here is ensure that each and every function is called at least once. Function coverage. Function coverage functions are nothing but the methods. In general, we term call it as the function. So here the functional means the function should be called tested at least once. Okay. And next is a mutation testing. So mutation means actually in generally the mutation means the meaning of mutation alteration testing. Mutation testing is nothing but the alteration or modification testing. So here in case of a mutation testing, here we ensure that the software does not fail. If it is good, if it is it is also a good debugging mechanism because mutation testing. See here in the mutation testing, that is what I said. The mutation means alteration testing. So why we carry out the alteration testing? Sometimes we modify our programs, we alter our programs, we alter our application for a testing purpose. So to make sure that that the software does not fail, and it is good debugging mechanism. Okay, it is also good after the software works correctly. After the software works correctly, here even your software is working correctly. The mutation testing is done to simulate a wrong input and reduce the risk. Okay, so here even after your application is working properly, your software is working properly, even though we carry out the mutation testing. So what is the use of mutation testing is we simulate the wrong inputs and reduce the risk. We simulate the wrong inputs. Okay, we simulate that is like a debugging process. Similarly, a debugging process, that is defect seeding. Simulate the wrong inputs and reduce the risk. So how we reduce the risk? Because we simulate the wrong inputs and we see the defects and we test. So it obviously indirectly reduces the risk only. Okay. Now in the mutation testing, the program is modified slightly to obtain a mutants of the program. See, in mutation testing, program is modified. As I said, the program is modified. Program is modified. Nothing but the program is modified or a program is altered. Program is mutated. Means see, the mutation means modified, altered. Now slightly modified to obtain the mutants of the program. To obtain the mutants here, the mutants means alterations of the program means when we alter a program, what is the actual output after the mutation? Okay, that is why we are going to test here within this mutation testing. Next, different mutants are tested with the same test cases. Different alteration are tested with the same test cases here. So why see? Okay, here the mutation testing program is modified slightly to obtain the mutants of the program. Now different mutants are tested with the same test case. Okay, different mutants are tested the same. Here the test case is only one, but the mutants are different. The mutants are various mutants. Means mutants here means various. So actually meaning of mutants means changing in the another form or alteration, altered in the another form. Now here if the mutant fails, actual program works correctly, confidence is gained in the program. Now if the mutant fails and the actual program works correctly, mutant fail means the alteration fails or the modified version fails and the actual program works correctly, the confidence is gained in this program. The test case are considered as a good. Okay, here the test case considered as a good when the mutant fails and actual program works properly. Now the different mutants give the different results because different alteration or different various formation or various alteration or various modified formats give the different results. Now each mutant have only one change. Okay, so this is all about the mutation. See, the mutation testing, just remember that the mutation testing is nothing but the alteration testing or a modified testing or giving a different meaning, or giving another form. So that is what the mutation testing. Okay, and now this is all about the mutation testing required to ensure the software does not fail. Means it's a good debugging mechanism. So debugging mechanism, because we alter and we test applications. Okay, so this is all about the mutation testing. Next is some mutation operations can be. Now, what is the mutation operations can be? Some of the examples for a mutation operations, or some of the aspects we use during the mutation testing. So, what is the mutation operations? Here, the constant replacements, constant replacement. Constant, so we have the constants, and we replace those constant and variable replacement. If you have any variables within your application, we replace those variables in arithmetic operator replacement, some relational operator replacements, relational operator something, but some conditional operator replacements, and go to label replacements. So we carry out these kind of the replacements or alterations or mutants. Okay, next, for example, we have here the code snippets, the 3-line codes. Here we see this input y means we are reading some value from the input, and we are assigning x to the sign of y, means sign, we calculating a sign of a y. If there is any problem of within a sign, if there is any problem, for example, we imagine that there is a problem within a sign function. So this method, this statement, that is assignment statement, x is assigned to the sign of y. So now here, if there is any problem, any problem in a sign function or sign method, then this x is going to give the error, because there is a problem. Now we need to test this. We need to alter and we test. We need to alter and we need to test this. So this is what the mutation testing. So the next is confirmation testing. Now, what is the confirmation testing? So when see, confirmation testing means we confirm. So generally we confirm the testing. So here what actually happens? For example, you are carrying out you are a test engineer. You are carrying out the testing process with it's on some module. Now, when the defect reported in the software, for example, there is any defect reported in your software, and developer makes some changes to the code, he makes some modifications to remove that particular defect. So what what happens when the developer indicates that you are a test engineer, you are testing application, and there is some error or some defect, and you send it to the developer, and developer removes or some modifies some code to remove that particular defect. When what actually in the next process is when the developer indicates that the defect has been fixed, it has to be confirmed by the test engineers. Okay, when the developer once the developer has fixed that defect, fixed that error, and it has to be confirmed by the test engineers only. Okay, because this is called as the confirmation testing. Means as imagine that you are a test engineer, and while testing your application, there is a defect encountered, any defect, and that you are giving that issue with the you are forwarding that issue with the developer, and developer makes some modifications and fix that error, and the developer once again, after modifying or fixing that particular defect, the developer again says that the defect has been fixed. And next process is as a test engineer, your work is to once again you are going to test that module. Okay, test that code, whether actually the defect has been fixed or not. So that is what we call it as a confirmation. So you are going to, the test engineer going to confirm. The test engineer is going to confirm about the the fixed defect. Okay, that is what we call it as a the confirmation testing. Okay, this is all about the confirmation testing. That's very smaller topic is there. So next is the regression testing. So what is the regression testing? Now here, the regression testing means when the defect is reported by the when the defect is reported by the test engineer, when the defect reported by the test engineer, developer will change the code and remove the defect. Developer will change the code and remove the defect. Now, change made in the code may lead to another defect. Means once in the regression testing, once you modify some part of the code has been modified, and at some extent, or in some cases or certain cases, that the modification part is going to affect some other parts, some other part of the module, some other part of the application. No, that that is what we call the regression testing. This is generally a general idea behind the regression testing is, if some part of the code has been modified and it's going to affect the another part. So now here, when the defect reported by the test engineer, the developer will change that code and remove defects. Now, change made in the code may lead to another defect that may not be visible immediately, because it's a change made in the code. So the changes made in the code lead to another defect that may be see once at the one part of the code you are going to alter, or one part of the code you are modified. So it is obviously sometimes not every time. Sometimes it may affect some other codes, some other modules. So they may be or may not be visible immediately. No, so one has to ensure that there are no ill effects. Ill effects means bad effects of the change on the other parts of the software. Now, regression testing here, so we ensure that in our regression testing, if any part of the code we are modifying, it should not affect the other parts. That is what we call it as the ill effect on the other parts. Okay. Now, to ensure that we should not have any ill effects, so that is we call it as the regression testing. That is we testing here. Now, regression testing, retesting. What is the regression? Now, regression testing done to ensure that the change in one part has no ill effect on the other part of the software. As I said, next is there are some difference. We know what is the retesting and the regression testing. In a retesting means done ensure that the fault is rectified by running the same test case repeatedly. We developed one test case, and we carry out the same, we execute the same test case repeatedly. Ensure that the fault is rectified. Fault is rectified by running the same test case. No? So regression testing. So what is that? Retesting means fault is rectified by running the same test case repeatedly, but in case of regression testing, done to ensure that the modification in code have no bad impact on other parts. Regression testing means modification in one code should not have any bad impact on other code of the other code or other modules. So this is all about the regression testing. So within this, I'll end this session now. In the next video, we'll see the next topic, that is the types of testing. Okay, in the next video, we'll see the types of testing. Okay, I am uploading these videos in the YouTube channel, my YouTube channel. Just go through this channel, that is Vishwanath Katti video lectures in the YouTube channel. Just go through this channel and watch the videos. Thank you.